We've only done 20 of these this year.
Yes.
Really?
Well, 21. We've been here for like 100 days.
And we've only done 20 of these.
Well, also, we didn't start them right away. Sometimes we do quick checks instead. Sometimes we do other stuff instead.
Oh, that's why. I thought these and quick checks are the same thing.
Yeah. This is like everything, but within 5 questions. And the quick checks is just one specific thing. Alright, for number 1, to find our slope, we have to remember this is y2 minus y1 over x2 minus x1. So this would be 1 minus 4 over 6 minus negative 3. 1 minus 4 would give us negative 3. 6 minus negative 3 would give us positive 9. Reduce. So negative 1/3 would be your slope. Questions on that one? For number 2, what is the slope of the line whose equation is y equals 3? There is a slope. It's just 0. For number 3, your range, you could write this in set builder notation or interval notation. This is going to start at negative 2, so in set builder notation, this would look like this. Y is greater than or equal to negative 2. In interval notation, you would start at negative 2 and go to infinity. Questions on any of those? Number 4. To find this equation, you need to know your slope and y-intercept. So your y-intercept at 1. Slope looks like it's at 1, 2, 3, 4, 3. Yeah. So y equals 4/3 x plus 1. And then the last one we have to graph. So we would start at our y-intercept of 3. Go up 2 to the right one as many times as possible. Down 2 to the left one as many times as possible. And draw a line through all of those points. Questions on either of those? Okay, then go back to your seat. Okay. If you haven't already, take out the notes that look like this, but find the page that looks like, it starts off with this. We're going to continue on the problem.
No. That's wrong.
I don't think those are the right ones.
If you have x2.
Again, the front of them look like that. There should be extras in the dark blue phrase in the unit 8 Punnett Squares.
Oh, so maybe coming up with
Strong. No, it would have been before that.
It's all right.
Yes. Yes. But then find this page. We did the first group. We didn't do the remaining.
You can start from the school.
And are you gonna be there all day?
I come back at last.
This should not be taken. I mean, the experts or something. Like extra certain.
Alright, so today we are going to be doing polynomial operations, adding, subtracting, multiplying things together. So when we are adding and subtracting, what you'll notice is that that's just like combining like terms. Your exponents will not change. You are just combining like terms. So let's do some of these.
That's a good one. What is
Number 1. If you are adding these two things together, you are really just looking at what is similar. So you'd be adding 6x squared and 2x squared. So 8x squared. You're not changing your exponents because you're not multiplying or dividing or raising an exponent to another exponent. You are just combining with terms. Negative 2x plus 7x would be positive 5x. And 3 minus 7 would give us negative. That is it.
Oh yeah, we did.
Yes, we did. We just didn't name it like this. So when you are adding different polynomials, so these are all of your different terms with different exponents together, your exponents are not changing. You're just combining. You do have to put it least to greatest, highest exponent first, until you don't have exponents. When you are subtracting, it's a little different. There are 2 different ways you can go about doing this, and I'm going to show both. One, you could take the negative, distribute it, and rewrite this. So your first polynomial would stay the same. And this would become negative 4x squared plus 7x plus 9. Now it's just a longer strand of numbers and letters. And then you would combine like terms. So here are like terms. We have 3x squared minus 4x squared, so negative x squared. 5x plus 7x, so 12x. And minus 6 plus 9 plus 3. One other way you could have done this, I'm going to write this higher up because I don't have space on this. If you have space in your box or somewhere else, you can rewrite this. I'm going to write the first. Again, 3x squared plus 5x minus 6. The other way you could do this is if you write them on top of one another, kind of like when we were eliminating. I'm subtracting this entire thing, 4x squared minus 7x minus 9. And then I could just subtract in line. 3x squared minus 4x squared would be negative x squared. 5x minus a negative 7 would be a plus. Negative 6 minus a negative would be a plus. So you would get the same thing either way. It's just your preference. Which one do you like better? Distributing and dealing with combining like terms, or just subtracting all at once?
So just adding like terms?
For adding and subtracting, yes. When we multiply, it's going to be different. Yes, but we'll deal with that in a second. Have any questions on 1 or 2 yet? Or so far? Okay. We're going to skip to number 6. This is a normal problem. How would we start this? Right. Distribute 5 to everything to become 5x minus 20. That has not changed. Now, when we go to distribute, we're just going to have more terms, more variables, or exponents. So then our exponent rules come into play. If we are still multiplying this, what are we going to be doing with the exponents? Adding. So still multiply the numbers together, but add your exponents. So negative 4x squared times x squared would be negative 4x to the 4. Negative 4x squared times negative 5x would be what?
Negative 20x to the
Positive 20x to the not second is already second, and this is 1. So to the third. And then negative 4x squared times negative 3.
Positive 12x squared.
Positive 12x. You know that there's nothing else to do because none of these are like terms. We can't combine them. It's least to greatest, highest exponent first. So that would be our final answer. What questions do we have on that one? Let's do one more. For number 8, 2x to the third, we're multiplying this out. What would that become?
14x to the 4th.
14x to the 4th. And not to the 4th, 30 to the third.
Me too.
Yes.
No, just geometry.
Same.
So if you're distributing, you are multiplying and adding your exponents. Move on to the next page.
Yeah.
There is a link to this that goes back to using algebra tiles, how you would do this using algebra tiles. If later you want to see that, we can do that, but we're not going to do that right now. It was kind of a mess doing it. There are 3 different ways to multiply binomials, so that's 2 sets of terms. We did this with radicals, but now we're going to do it with this regular term. One way is using this, what is it called? Yes, that's what that actually says. I was trying to think of the word you use when you put letters to words, acronyms, something like that. Yeah. This stands for first. So first is going to be your x times x. We'll figure out what it actually is here in a second. Yeah. Your O is going to stand for outer. Your x times your 7. Inner.
Why you just?
Relax.
Good. So 5 times x will be your inner. And then your last would be your 5 times 7. So it's a way to distribute in a certain order. Multiply your first together, your outer together, your inner together, and then your last. And then see what you get and combine them through. So x times x would give you what?
X2.
X squared, because you're adding the exponents. 7 times x will give you 5 times x will give you, and 7 times 5 will give you 35. Find your like terms, add them together. You'd end up with x squared plus 12x plus 35. And that would be your final answer. So that's one way you can do this. And if you like that, keep going with that. I'm going to show you 2 other ways that do the same thing, just in a different format. Before I show you those other 2, what questions do we have on this one? We combine 7 and 5. Right. On number 2, this is the second way you could do this. Still distributing, but it's rewriting, like when we were doing the radicals and distributing. We're going to do it like that. So we're still doing that method, but we are just doing it a little differently. So here, I'm going to take my x, multiply it to everything that comes second, but I'm going to rewrite it first, just so it looks like it makes more sense. And then take my 9 and multiply it to everything that's in the second. This is the exact same thing as the first one, it's just written differently. So we would distribute x times x would give you x squared. X times -6 would give you -6x. 9 times x would give you 9x. And 9 times -6. -6. And then combine my terms. So x squared plus 3x minus 54. So FOIL and this are basically the same, it's just how you rewrite them. Questions on that? The last method, I like this one, and it's still doing the same thing as the other 2. You just visually see it a little better. I don't know which science class this is taught in, but those of you that have seen this before, how many of you remember learning something about Punnett Squares? Okay, this will kind of go along with that. So whatever this is a 2 by 2, so you can draw a square with 4 boxes. Mine's more of a rectangle, but that's okay. It does not matter which 2 you put on which side, but make sure you include the signs. So I'm going to put 5x plus 2 up here, and x minus 4 over here. And then we're going to take each thing and multiply it across, diagonal, whatever. X times 5x will give you what? 5x squared. X times 2, 2x. And we're going to put that this is positive since this had a positive sign. 5x times negative 4. Negative 20x. Negative 20x. And 2 times negative 4. Negative 2. Not negative 2, but negative 8. Then you can easily see what your like terms are. Positive 2x and negative 20x. Start with your highest exponent, so 5x squared. Combine your like terms, so negative 18x. And then put your constant. So you get the same format answer, it just looks different. Do you have any questions on that method? Like reset it. Second plus 7, 1, 2.
If you have like these 3 different things, like these 3, how would you do that?
I would say you would need to multiply 2 of them together, and then the third. I think this is number 7. Yes, spelling. I'll write your class as soon as we finish this. I'm going to show you how to do this one in 2 different ways, and then you pick and choose which one. So I'll do the longer method first. For the longer method, this is like the second method I showed you, where you take one thing and multiply it to everything and kind of rewrite it. We're going to be doing that. We're going to take the x and multiply it to everything. So that would be x times x squared plus 3x plus 4. And then I'm going to take the 2 and multiply it to everything. So that would be plus 2 times x squared plus 3x plus 4. Then I'm going to distribute everything and see if there's like terms, and then combine and deal with that. X times x squared would give you what? X to the third. X times 3x. 3x squared. And then x times 4 would just be 4x. And then multiplying 2 to everything. 2 times x squared would be 2x squared. 2 times 3x 6x would be 6x. And then 2 times 4 would be 8.
Wait, so that would have the polynomial as our
Say that one more time.
So we'll have polynomial as our answer.
Yes. I mean, these are all polynomials and other things. So if you have just one term, that's a monomial, but it's also a polynomial. Actually, that one's not really a polynomial. It falls under the branch of polynomials. Binomials is 2, but it's also a polynomial. Trinomials is 3, but it's also a polynomial. So, like, it doesn't really matter. They're all polynomials. And then combine the terms. So, x to the third, you don't have any, so that's just going to get brought down. You have x squared. That would be 5. Here you are just combining like terms, so your exponent should not change anymore at this point. 4x and 6x. We give you 10x. And then the 8 at the end doesn't have anything. So that was one way to do this. That was the longer way to do that. If you like seeing that you're distributing to everything, do that. The other way you can do this is going back to your box method. You would just need a longer box. If you wanted to do it, I did it 2 by 3. If you wanted to do it 3 by 2, that's fine too. It doesn't matter. And you're going to put x plus 2 where your 2 is, 2 squares. And then your x squared plus 3x plus 4 where your 3 is. Then just as before, multiply everything. X times x squared, x to the third, x times 3x,
3x
x times 4.
4x,
X squared times 2,
2x squared,
3x times 2,
6x,
and 4 times 2.
8,
Look for your like terms. You have x squareds and x's. And then write out your final answer. Highest exponent goes first. This should be plus. This would be plus 5x squared plus 10x. So the second method is faster, but you get the same result. What questions do we have on this? Right. I'm going to have you guys go back and do, on the first page, numbers 3, 4, 5, 9, and 10. And on the second page, 4, 5, 6, and 8. And then work through those. Towards the end of class, we'll go over those. If you finish those relatively quickly, you do have 2 Khan Academies and 1 Delta Math. Khan Academies are due on Friday, even though we don't have school. And the Delta Math will be due next class. Your SOL A.2abc is also due next class, so once you finish those problems, you have other stuff you can be working on. Anyone have questions on what we're doing? Three, 4, 5. I need everyone's attention first. Pay attention. Number 3, 4x squared plus 3x plus 3. Questions on that one? Number 4, 7x squared plus 12x minus 8. Questions on that one? 5, 9x squared plus 3x minus 3. Questions on that one? Number 9, negative 18x to the 4th plus 3x to the 3rd minus 3x. Questions on that one? Number 10, 6x to the 5th plus 8x to the 3rd minus 10x squared. We good with those? And then number 4, 6x squared minus 17x minus 10. Number 5, 12x squared minus 56x plus 9. Number 6, 15x squared plus 4x minus 96. Questions on any of those? And then number 8, negative 6x to the third plus 20x squared plus 3x minus 3. So next class, before you start packing up, listen really fast. Next class, we're going to be going over SOL A.3. Make sure that is done. Make sure you do those 2 concatenates that are due on Friday. Make sure you do your Delta Math that is due next class. We are going to be reviewing next class, but then your test isn't until Monday. Does anyone want that review?